and the chain rule. So before we start, let's remember something. So remember the power rule, right? So let's say you want to find the derivative of negative 5x. Well, we said that is just negative 5, and this is x to the power 1. So you bring the 1 in front, and then x to the power 1 minus 1, which is equal to negative 5 x to the power 0, which is equal to negative 5. This is just the power rule, remember this. The important thing that I want to notice here is that if you did instead negative 5 times the derivative of x, right? This would be the same as negative 5 times, well, this is x to the power 1, so you bring the 1 in front, 1, and then x to the power 1 minus 1, which is 0, which is equal to negative 5 as well. So multiplying by a constant, if it's positive or negative, does not change the outcome of what the derivative is going to be. So I wanted to get that clear. Now let's take trigonometric derivatives. So far we've been dealing with polynomials. A polynomial is like x squared plus 3x minus 5 plus 2 over x. These are all polynomials. But what if we had the function y is equal to sine of x? Because this is also pretty common. Trig functions are very common. Let's start with sine of x. Okay, how should we do it? Let's think about it before I give you the answer. So let's draw y is equal to sine of x. Let's remember what it looks like. So we have y-axis, we have the x-axis here. And I'm gonna need a few angles. I'm gonna need 0, I'm going to need 90, I'm going to need 180, I'm going to need 270, and I'm going to need 360. I'm just going to draw a rough sketch. Sine starts with 0, reaches 1 at 90, and then goes down to 0 here. It's meant to touch 0, so we'll draw that again. So it goes up, comes down, touches 0, goes down to negative 1, comes back up, goes back to 0. So this is 1, and this is negative 1. This is just y is equal to sine of x, right? This is sine of x. Now let's do something. Let's draw another graph, and what this graph will be, I'll show you what this graph will be. We'll have 90, 180, 270, and 360. Okay, let's do 1, and let's do minus 1. Now, I want you to look at the derivative of sine at 90. If you draw a tangent to sine at 90 degrees, you'll see it's a horizontal line. That means the derivative is 0. So let's put the point 90 and 0 over here. And I want you to draw the tangent to the line at 270, and again, of course, the derivative is 0. So put another point at 270 and 0. Now, if you want, and this is a good exercise for you, you can draw a tangent to the sine graph at 0. So you can draw a tangent like that. And if you calculate the gradient of this tangent, you'll see it's equal to 1. And if you calculate a gradient at 180, let's say you draw a tangent here, and then you calculated that gradient, that would be negative 1. So we have another point here. And then at 360, if you drew another tangent and calculate the gradient, I'm telling you it's going to be equal to 1 again. I would do it, but then there's not enough space to draw proper tangents and do it properly. So let's connect these points together. What do we get? We get something that looks like this. We get a graph that looks like this. And this is the graph of the values of the tangents of sine of x at different angles. But this is a very familiar graph. This is actually y is equal to cosine of x. So what does that mean? That means that the derivative of the sine of x is actually equal to the cosine of x. That's an interesting relationship that we have. We never thought of sine and cosine as being derivatives, as the cosine of being the derivative of sine. And you can do the same exercise again. So now you have cosine of x here. You can draw a tangent over here. It's going to be 0. You can draw a tangent here. You can draw a tangent here, 270 and 360. And we're not going to do that, but I'm just going to write down the answer. And you would think it would be the sine of x. The derivative of cosine would be the sine of x. And you would be almost correct. It's actually equal to the negative of the sine of x. Yep, just have to remember that. It's going to be negative here, but with sine, it's just going to be positive cosine of x. What will be the derivative of negative sine of x? Well, we said that we don't really care about the negative sign. We can just get rid of it for now, so we can just put the negative in front. And then we can take the derivative of the sine of x. But we already know what that is. That is the cosine of x. So from negative sine of x, we have negative cosine of x. Let's take the final derivative. Let's take the derivative of negative cosine of x. And what do we get? Well, we don't care about the negative, so we can put that in front. And then derivative of cosine of x is negative sine of x. So negative sine of x, which is equal to positive sine of x. And we don't need to take any more derivatives because we can just repeat the cycle now. So sine goes to cosine, cosine goes to negative sine goes to negative cosine goes to positive sine, and then you can repeat this cycle. Just for the sake of having it, I'll put the derivative of tan of x, and that is equal to secant squared of x, just in case you were curious. We'll show why this is true in another video on the quotient rule and product rule, but secant squared is just 1 over cosine squared of x. I just thought I'd mention it just in case you're curious, but we don't really need to worry about this right now, so might as well cancel it. Alright, we did trig derivatives. Now let's focus on the chain rule. So this is probably the most important rule when it comes to differentiation. So let's say you had y is equal to sine of 2x. How would you find the derivative of this? So what's dy by dx equal to? Well, we now have to find the derivative of sine of x, which is equal to cosine of x. But this is sine of 2x, so would it just be cosine of 2x? Let's put cosine of 2x. Question mark? Is that a valid guess? And you're almost correct, but let's think about it in a better way. So we're going to abuse some notation here. So we have dy by dx, right? Let's introduce a function t. Let's say t is equal to 2x, right? Because we have 2x here. Let's call it t is equal to 2x. So now we have y is equal to sine of t, right? So far we haven't really done anything. It's just calling t equal to 2x because we don't want the 2. So t is equal to 2x. Now, what if we take the derivative of x with respect to t? So dt by dx. So we just take the derivative of x. That's all this is saying. Well, we don't have to do that. Take the derivative of 2x. That's just 2 times x times 1 times x to the power 1 minus 1, which is equal to 2. So we have dt by dx is equal to 2. And what's the derivative with respect to t of y? Let's say dy by dt. So like of this function right here. Well, that is simple. That's just cos t, right? If you remember, here we did derivative of sine of x is equal to cosine of x. If you replace x with just t, you would get dy by dt is equal to cos of t. Now, but we need dy by dx, and we don't have dy by dx over here anywhere. We have dt by dx, and we have dy by dt. But what if we did something? What if we did dy by dx is equal to, let's think, we can work with fractions. What if we did it as dy by dt times, this is multiplication, dt by dx? What if you did that? Well, you can see the dt here would cancel out, right? And we would be left with dy divided by dx. Well, that's what we need. We need dy by dx. So let's try it. Let's try dy by dt. So dy by dt is cosine of t. We have that. Times dt by dx, which is equal to, we found that over here is equal to 2. So multiply that by 2. And you're left with 2 times cosine of t. But You have to remember, you can't write it in terms of t because we're asking dy by dx. You need it in terms of x. But we know what t is. T is equal to 2x. So now we just put it back in. So we're left with 2 cosine of 2x. And that's it. dy by dx is equal to 2 cosine 2x. We estimated it would be cosine 2x. We didn't know how to do it. And we were pretty close, but this 2 is very different. This 2 cosine 2x is very different from just cos 2x. And the chain rule is so important because let's do a harder function. Let's do y is equal to 4x plus 3 to the power of a half. Let's say we have that. How would you find the derivative of that function? Like, we don't know how to do that. That's insane. But we know that, let's say y, like we can let t equal 4x plus 3, right? So now we have y is equal to t to the power of a half. Well, we need two things. Well, what we really need is dy by dx. That's question mark. But we don't know how to get that. But what we can get is we can get dy by dt. And we can get dt by dx. Well, dy by dt is equal to, if you multiply these two, you would get dy by dx. dy by dt is equal to, take the derivative of this function right here. So you have a half in front, because the half goes here from the power rule, times t to the power of a half minus 1, which is negative a half. So you have that there. And then you have dt by dx, which is equal to, let's actually do it on the left side. You have dt by dx, which is equal to, well, t is just 4x plus 3, so we just do the power rule on x now. That's 4 times 1 times x to the power 0, which is just 1, plus 3 times 0, x to the power 0 minus 1. Well, this cancels out, of course, and you're left with just 4. Well, now we know what to do. dy by dx is dy by dt times dt by dx. So we have dy by dx is equal to 4 times, and what's dt? So we just did dt by dx times dy by dt is the same thing. You change the order around. And dy by dt is a half t to the negative a half. Well, remember, it has to be in terms of x, but we know what t is in terms of x. So we can do 4 divided by 2 straight away. We have 2, and then t is just 4x plus 3. So you're left with 4x plus 3, and then a negative a half up there. And that's it. That's the derivative of this function right here. We would have no idea how to do this, but as soon as we let t equals 4x plus 3, we take the derivative of x with respect to, we take the derivative of t with respect to x, we get just 4 right here. And we take the derivative of y with respect to t, and we get a half times t to the power negative a half. Multiply them together, you end up getting 4 times a half times t to the power negative a half. 4 divided by 2 is just 2. And we already know what t is. T is 4x plus 3. Put 4x plus 3 back in, and the negative a half power, and that's the derivative. Alright, let's do one final example. Let's say we have y is equal to, let's put everything that we've done together. We have 4 sine 2x plus x all cubed. How do you find the derivative of this function? So we need dy by dx. Question mark. Well, so we need two things. We need dy by dt, and we need dt by dx. This x right here is multiplication times dt by dx. Well, as you've noticed by now, we just let t equal the thing inside the brackets usually. So we can let t is equal to 4 sine 2x plus x. So now y is equal to t cubed. Let's do dy by dt first, because that's pretty simple to do. So dy by dt is just the simple power rule that we know. So that's just 3 times t to the power 3 minus 1, which is 2. So we have 3t squared. Okay. Now dt by dx, how would you do that? Dt by dx is equal to 4 sine 2x. Well, we know, let's just deal with 4 sine 2x first. We can worry about the x later. This is very easy, but 4 sine 2x is more difficult. Well, we know it doesn't matter if you multiply by a constant, so we just put 4. And then we take the derivative of sine of 2x. Well, we already took that, right? We found that to be sine of 2x. We took the derivative, found that to be 2 times cos of 2x. We can put that back in. So now we have 4 times 2 cos 2x in brackets. And then plus the derivative of just x to the power 1, which is 1 times x to the power 0, which is just 1. We have dt by dx, and we have dy by dt. Now we multiply them together. So now we have 3 times t squared times this whole thing. So you have 8 cos 2x plus 1. But we know what t is. We let t equal 4 sine 2x plus x. So now, this is dy by dx. We can't just leave it in terms of t because we want it in terms of x. We're doing it with x right here. So that is actually equal to 3 times, and it's multiplication, so I can just put 8 cos 2x first. 8 cos 2x plus 1. And then times t squared. Well, t is 4 sine 2x plus x. And then this thing is all squared. This bracket is squared. Let me just draw them brackets nicely. That and that. And that's the derivative. So if you want to write it very clearly, you can write 24 cos 2x, because 3 times 8, 24, plus 3 times this whole thing right here, 4 sine 2x plus x, and this bracket squared. And that's dy by dx. So you can see how important the chain rule is. This looks like an impossible derivative to take, but it's actually very easy. So we let t equal a function inside the bracket usually, and we find dy by dt, which is just, it's always going to be very simple if it's a power, so that's 3t squared. And then we find dt by dx, which in this case we had to use our trig derivatives, but that was very easy. And actually this right here, this 2 cos 2x, is also actually the chain rule. So, because if you remember from here, the way we found the derivative of this was we used the chain rule here as well. So what we've done actually is we have used the chain rule 2 times to find the derivative of this function right here, of y is equal to 4 sine 2x plus x, all cubed. So you can see how important the chain rule really is. And you can simplify this, and you're left with this. One important thing I have to mention, I cannot like stress this enough, is make sure your answer is in terms of x and not t. So you have to make sure you put x back into where t is. Otherwise, you will not have the right answer, because it's it's dy by dx. It's not dy by dt. So what have we learned today? So we've learned about trig derivatives. We've learned about chain rule. Honestly, that's all we've learned, but we have learned how important the chain rule actually is. Because you're taking derivatives of things that you don't even know what this looks like. You don't know what 4 sine 2x plus x cubed looks like. But if you want to find the gradient of it for any reason at all, and obviously turning points, and there are many applications of differentiation, but you can just take the derivative, and imagine having to draw this curve right here. That is an insane curve to draw. I don't even know what it looks like. But if you just take the derivative of it, then you're good. You can find out all the things that you need to know, and you'll be good from there. So yeah, we've learned about trig derivatives, we've learned about chain rule, we've learned about how important the chain rule is. And yeah, that's it. I do want to make a video on the quotient and product rule, and we're going to go over why the derivative of tan of x is equal to the secant squared of x. So yeah, keep a lookout for that. Yeah, like, comment, subscribe, and yeah, let me know how Let me know what you want to see, actually.